So let us start the second class today now, that is physics. Okay, today is 7th September 2020. In the physics, we had already discussed many terms or physical quantities which are associated with the electricity. Alright, so now today I am going to solve the exercises in the textbook that are given to you. It is in page number 186 and it is exercise 8A. Now from questions 1 to 20 I have already given you the assignments, and I have already given some the answer key also. I have sent it in your WhatsApp in the class group, so you have to write it down from there, or you can also do it yourself by going through the classes that I have already discussed. Now some of the important questions I am going to do. If you look at question number 21, there are two graphs given for the two resistors. This is called the VI graph or IV graph. Very simple questions will be there. So last time we have discussed the first A is given curve like this, and the second is given to you B, a straight line like this, and these are the two resistors, and you just have to identify out of these two resistors which is the ohmic resistor and which is the non-ohmic resistor. Obviously A is the non-ohmic resistor and B is the ohmic resistor. So what is the difference? Why it is a non-ohmic resistor? Because it is a curve. And why it is a ohmic resistor? Because it is a straight line. Because straight line means the resistance is constant, and here the resistance is not constant. Alright, this is question number 21. You have to do this. Likewise, there are one more question is there which is very simple. All of these questions will carry 2 marks, and sometimes it will be 3 marks. Look at question number 24. If I read this question, you have to write down the order of the specific resistance of the following. Number A is a metal, number B is the semiconductor, and number C is an insulator. For this, the value, okay, now you have to tell the values of the specific resistance which we have already given as symbol rho. If you look at the textbook in page number, again you will find that in page number 183 you will find a table. In that table you have got 3 categories of these materials or the substances. Metal is there in the first, then you have a semiconductor. In the metal you have different types, like you have silver, etc, it goes on. Then you have a semiconductor. In the semiconductor you have graphite and all that, and in insulator you have wood, etc. So if you look at the value of the semiconductor, it increases from less to the high. For the metal, it is very low for the metals and the alloys. It will be in the negative 10 to the power minus 8 ohm meter. Last time we have learned that this is the unit of a specific resistance. It is negative to the power negative, very less. But for the semiconductor also it is low, but it is slightly more than the metal. For the semiconductor, the value of the resistance will be in the negative of minus 5, 10 to the power minus 5. And for the insulator it is slightly high, because in the insulator the electrons do not move. So for the insulators you have got in the positive 10 to the power, I think 13 is very high for the insulator. It is 10 to the power 13 ohm meter. So please go through this table and you try to see some of the values for the specific resistance of a metal, semiconductor and an insulator. Likewise, the rest of the questions are there, very simple. You have got 1 word, at the most 1 sentence answer, and everything is discussed you have to do that and complete it. Now, we have learned in the previous class many formulas. Now, using that formulas, we will do few numericals here. Numericals, it is there in page number 187. There are total questions 13 from 1 to 13. I'll solve you few today and the rest you have to do it yourself. Let us start with the first question given in the textbook. I've jotted down the questions here. The first one, in a conductor 6.25 into 10 to the power 16 electrons flow from its end A to B in 2 seconds. Suppose this is the conductor and A to B. The electrons is how many electrons? That is N, the number of electrons. 6.25 into 10 to the power 16. So many electrons are there and it's flowing from A to B in 2 seconds time. Find the current flowing through the conductor. Now, since if this electrons is flowing from A to B, the current will flow from B to A, just the opposite of the flow of the electrons. And also it is given that the charge on each electron will be one, it will be negative, but we will not write that because since we have to find only the numerical. So these are the three data provided to you. There is a conductor. In this conductor, there are how many electrons? 6.25 into 10 to the power 16, no unit. And the electrons is flowing from A to B. How much time it is taking from here to here? 2 seconds. And what is the charge on each electron? This much. So you have to find the current. So we have learned that the formula for the current is I equals to Q by T, if you recall this. Yes or no? Now, Q is the charge. And what is the charge? The charge is the number of electrons present in a conductor. And we also know the formula of the charge, N into E by T. Okay? So now it becomes quite easy. N is the number of electrons which is given to you into E is 1 electron. So what is the charge on 1 electron? 1.6 into 10 to the power minus 19. And how much time it is taken? 2 seconds. And the unit of the current is ampere. Now if you see there, 6.25 into 1.6, suppose you multiply this or you solve this, 6.25 into 1.6, it will come around roughly 10.05, something like that. Then this will be using the law of exponents, it will be minus 3 upon 2 ampere. 2 into 5, 2 5s are 10. So roughly we can write down 5 into 10 to the power minus 3 ampere. So what is the current flowing in the conductor? 5, 10 to the power minus 3. 10 to the power minus 3 is very, very small, and 10 to the power minus 3 we can use it as microampere, small m. Sorry, milliampere, not micro. Micro is 10 to the power minus 6. So we can replace 10 to the power minus 3 as milliampere. So how much current is flowing in that conductor AB? 5 milliampere. So this is a simple numerical. 6.25 into 1.6, slightly difficult in terms. Sometimes some may take a lot of time in that multiplication. So it will come out to be 10.05. So 10.05 is almost equal to 10. So when you divide by 2, you get 5. So 10 to the power minus 3, if you replace it, you'll get a smaller unit of the current, which is milliampere. If you have more smaller, that is microampere, which will be 10 to the power minus 6. So like that, you have to solve it. Formulas are very, very simple. Let us do one more question here. If you look at the textbook, question number 3. This is very, very simple question. Find the potential difference required to flow a current of 200 milliampere. So given in a conductor there is already a current flowing. So what is the symbol of the current? We always write with the symbol I. And how much current is flowing there? 200 milliampere. You have just learned that milliampere is actually what? 10 to the power minus 3. And in a wire, it is flowing in a wire or a conductor current, and that wire is producing a resistance of 20 ohms. So resistance is given by capital R, and how much resistance it is there? 20 ohm. This is the unit of the resistance, ohm. You have to find the potential difference. Potential difference that is acting across the end of the wire. The current is flowing and the wire is offering a resistance. Now to find that V, you have to use Ohm's law. So we know from the Ohm's law, V equals to I into R. Okay, so now what do you get here? I, how much current is there? 200 milli, you have to change it, 10 to the power minus 3. Resistance is 20. So if you solve this, 2 into 2, 4, then you have 3 zeros, that means 10 to the power 3 into 10 to the power minus 3 volt. 10 to the power 3 and minus 3 cancel, so you get 4 volt. 1, 2, 3. This 3 is the positive, and this negative 3, minus 3 is, it has come from milliampere, because the current, the unit, SI unit is ampere. So we have to change that milli into ampere. Alright, so it's very, very easy. If you solve this much, you will get 3 marks in your exam. So V equals to I into R. Okay, let me do one or at least two more. So you get the idea how to do it. It's very, very easy. Question number 5 in the textbook. A car bulb. There is a car bulb, let us say. This is a filament. A car bulb is connected to a 12 volt battery. So given 12 volt. If you do not know what is that 12 volt, look at the unit. 12 volt. That means volt means it is potential difference, and the potential difference is given by V. The unit and the symbol are same. When blowing, it draws the current. When it is connected to a circuit, okay, it draws the current. So current is flowing. How much current is drawing there? 2 ampere. Connected when glowing. Glowing means when the circuit is closed, the current is flowing. What is the resistance of the filament of the bulb? It's very, very easy. The same formula that you have learned you have used in question number 3. So we know that resistance is V upon I. It's so easy. This is also from the Ohm's law. Volt is 12, current is 2, so it will be 6 ohm. Therefore, the resistance will be 6 ohm. And there is also the second part of the question. It says that will the resistance be more, less or equal when the bulb is not glowing? So when the bulb is not glowing means it is disconnected, the circuit is open and there is no flow of the current. So when the current is not flowing means there will be no heat there. That means no heat means the temperature will be less. So when the temperature is less, the resistance will also be less. So it will be less, because we know that resistance of a wire is directly proportional to the temperature. So when the bulb is not glowing means no current. When no current means no heat. When no heat means the temperature is less. Therefore, the resistance will be less. So this is the second part of the question. Resistance will be less when the bulb is not glowing. Very, very simple. This may be of 2 marks and this may be of 1 mark, so 3 marks is in your pocket. See, a very very simple formula is there. If you know the symbol well and the unit, then it becomes easy. Now we have one more question is there, so let us solve this also. Question number 8. Look at question number 8 now. Two wires of the same material, there are two wires of the same material and same length. Okay, there is a wire 1 and there is a wire 2. Both of them are made of the same material. For example, these are the two wires, same length. Let us say the material is also same. Let us say both are the copper wire. But the radius is different, means the area cross section is different. See, this is a thicker wire and this is a small, thinner wire. So they have a radii. Suppose let us say radius 1 is 1 millimeter and radius 2 is 2 millimeter. Okay? You have to compare their resistances. Now this is a thin wire, means obviously it will have more resistance. This is a thick wire, means it will have a less resistance, because we know that resistance is inversely proportional to the area cross section. The thicker the wire, resistance is less, more flow of current. Thinner the wire, the resistance is more, less flow of current. So length is same in both the cases. And what is same? The material is also same. The material also same means the specific resistance is also same. But the resistances will be different. Let us say R1 and R2. We have to find the resistances. So resistances is in terms of specific resistance. Okay, so like this you have to solve it. Now, the specific resistance for both is rho, the length is also L. Now, area of the cross section, suppose this is a wire, this is the cross section, and look at the shape of the cross section. It is a circle, and we know that area of circle is pi r square. R is 1, no need to change, so just write down 1 square is 1 only. Yes or no? A specific resistance is same, the length of the wire is also same, area is pi r square, but here the radius of the second wire is more, 2, so 2 square is 4. Now you have to compare these two, so comparing means R1 is to R2, pi 4 pi. Everything cancel, you get 1 by 1 is to 1 by 4. After cross multiplying, you get 4 is to 1. Or just taking it intersection cross product. So what is the ratio of their resistances? The resistances, the ratio will be 4 is to 1. Number 2, what will be the specific resistance? The specific resistance will be same, 1 is to 1, because the specific resistance of the two wires will be same, because both of them are of the same material. So like this you have to go on solving it. In this way you have to do all the numericals, whatever is remaining there from question number 1 to question number 13. If you have any doubt, then you can send the question to my WhatsApp page, then I will discuss in the next class. In the physics now, in the next class, maybe we will come tomorrow, I will discuss another topic, that is electrical energy and power. Thank you very much. Have a nice day.